Hello, my little mathematicians. We're going to go ahead and review some prime factorization. Let's go ahead and turn to page HL-922. Number 1 says find all the factors of 48. So when you're listing all of them, go in order. Okay, so start with 1 times 48, and then can 2 go in? Yeah, it goes in 24 times. Can 3 go in? Remember the divisibility rule for 3. 4 plus 8 is 12. Can 3 go into 12? Yes, so 3 can go into 48. So you're going to divide how many times can it go in. And you'll figure out that it goes in 16 times. Okay, can 4 go in? Yes, it goes in 12 times. Can 5 go in? No, it doesn't end in 5 or 0. Can 6? Yes, 6 times 8. Can 7? No. 8 is already used, so now I know that I have all the factors. And that's why I like going in order, because then it kind of gives you a stopping point. And then you just follow the U. Go down and then back up, and that lists them all in order. So 1, 2, 3, 4, 6, back up, 8, 12, 16, 24, 48. And that's listing all the factors of 48 in order from least to greatest. Okay, remember you can always pause the video at any point in time, try them yourself, unpause them, and then come back and join us and check yourself. All right, number 2 says this time we want to find not just all the factors, but we want to do the prime factorization of 48. So this time is when you just want the prime factors. So I think the easiest thing is let's do a factor tree. Okay, and then there's so many different ones that you could do. I like the bigger you start with, the easier. You could do 6 times 8. 6 breaks down to 2 and 3. 2 can't break down anymore. 3 can't break down anymore. 8 can break down to 2 times 4. 2 can't break down anymore. It's prime, but 4 can break down to 2 and 2. And now they all ended. Okay, so each branch of the tree ended, and now I'm done. So I list the smallest base to the biggest base. So my smallest base is 2, and I'm going to use exponents to represent how many 2s do you see? 1, 2, 3, 4 2s. And then if you want, you can like cross them off to make sure you have them all. And then you also see a 3. So 2 to the 4th times 3. If you want to be safe, you could always multiply this out. 2 times 2 times 2 times 2 times 3, and you should get the same number you started with. And of course, if you got a different tree than me, don't be like, oh my gosh, I missed it. There's so many ways. As long as you end with this answer, you're correct. But you could have done 4 times 12. That breaks apart to 2 and 2. Even from this, you could go 2 times 6, or you could go 3 times 4. Okay, you pick one. I'm going to do 3 times 4, and then 2 times 2. Okay, you still end with 1, 2, 3, 4 2s and a 3. Okay, there's so many different routes. You could have done 2 times 24, or even this 4 times 12, you could have done 2 times 6 instead of 3 times 4. So many different ways we could have gotten there. All right. So as you're pausing the video and trying these yourself now, for like number 4, remember, if your factor tree looks different, that's okay, as long as you get the same final answer for number 4. But number 3, we should all do the same way. List all your factors, starting with 1, and then go in order, and then keep going till you can't go anymore. And once you get to a number that's already been used, you know you can stop. Okay, so you can pause it, try it yourself, and then come back and check. Okay, now that you're checking, you did 1 times 60. It's even, so you know 2 can go in. It goes in 30 times. 3 goes in 20 times. 4 can go in. So it would be half of that, which is 15. And then it ends in 5 or 0, so I know 5 can go in. 5 times 12 is 60. 6 times 10. 7 cannot go in. 8 cannot go in. 9 can't go in. 10 is already used, so now you know you have them all. So you should have gotten 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. If you missed that, it would be wise to go back and review the divisibility rules that we learned about in first quarter. Okay, so review your divisibility rules. That'll make these a lot simpler. Number 4, Again, if your factor tree looks different after you come back from pausing the video, it's okay as long as we both get the same answer. I'm going to do 6 times 10. 6 can keep breaking down to 2 times 3. 2 is prime. 3 is prime. But 10 can keep going to 2 times 5. 2 is prime. 5 is prime. So now I'm done. Okay, 2 is the smallest base, and there's 2 of them. And then there's also a 3, and there's a 5. If you were to double check this, 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60, which is what I started with. And each of these is prime. Because remember, it's the prime factorization. So all the factors that you're left with need to be prime numbers. All right, and our final problem. Number 5 says, Alexa has 30 beads. She wants to put them in boxes so that each box will contain the same whole number of beads. Use factors to list all the different possible ways that she can put the beads into boxes. Okay, so first of all, I need to list all the factors of 30. So you have 1 times 30, 2 can go in 15 times, 3 times 10, 4 can't go in, 5 times 6, 6 is already used, so this is all of them. So this means I can do 1 box with 30 beads. Okay, so I can have 1 box with all 30 beads, right? I could also do 2 boxes with 15 beads. Okay, and I mean, I think we get the point. I don't need to write these words out anymore. But we can do 3 boxes with 10 beads. We can do 5 boxes with 6 beads. And then most of us would think that we can just stop right there. But can we? Actually, there's another whole set of possibilities, because instead of 1 box with 30 beads, all 30 beads in 1 box, I could do 30 separate boxes, each having only 1 bead in there. And I could do 15 boxes that each only have 2 beads in there, and 10 boxes that have 3 beads, and 6 boxes that have 5 beads. So those are all the different possibilities of how I could organize these so that they each have the same matching amount. So you find all the factors, and then you could do it one way, and then you can also double that amount because you can flip it and do it the other way as well. All right, if you got all those right, congratulations, my little mathematicians. If not, go ahead and review it, try these again, and good luck. We have now mastered prime factorization.